Welcome back, everyone. Hopefully things are still going well at home. In the meantime, here we go again. I just realized how many feathers there are on this blanket. This is the problem with me. You have ducks. Sometimes they get everywhere. So let's look at simplifying radicals. As we talked about yesterday, this is often a geometry topic or it sort of bleeds into it, but we start it in algebra. So the first thing we have to do is figure out the vocabulary, and I actually think that's the hardest part of this unit. So as we look at this, oops, undo that. Oh wait, redo. Go backwards. Okay, so the first thing we're going to look at is parts of a radical. So we need some vocabulary terms. Now, not surprisingly, if we're talking about parts of a radical, this is actually what we call a radical symbol. You guys have probably heard about it as a square root symbol, and it is one, but only if the index is 2. So there's the radical symbol. This is called the index. The index is how many groups of things we need to have in order to pull them out, and that'll make more sense in just a moment. This is called the coefficient. It's the multiplier out front. We use the same word when we talk about 3x. 3 is the coefficient. And finally, the newest term, the radicand. It sounds like a really weird word, but what it really means is the number under the square root symbol. So to simplify radicals, we're going to do a couple of things. We're going to find the prime factorization of the radicand, the number under here. And we could practice with that with numbers. Now you're going to see how it works with variables as well. The index of the radical tells you what size of identical groups can be removed, and circle these groups. So if we have an index of 2, we're going to look for groups of 2. If it's a group of 4, an index of 4, we'll look for groups of 4. For each circled group, the number or variable will be multiplied by the coefficient of the radical one time. If everything is removed from the radical symbol will disappear. So let's look at this example. Here we have an index of 2 and a radicand of 28 x to the third y z to the eighth. So what does that mean? Well, if we factor 28, we get 2, 2, and 7. Well, there's two groups of 2 there, so the first thing I'm going to write is 2. Okay, now what? Well, when I look at this x cubed, that's really x times x times x. There are 3 x's, so I'm going to pull out 2 of them. And for each time I pull them out, I'm going to end up with just the one. So I'm counting groups here. So I'll have x on the outside. Hang on for what happens to that third x. Can we touch the y? Well, there's only one of them, so there's no pairs. So we can't touch y. For z, if there are 8 z's, there are 4 pairs. So we end up with z to the fourth. You're going to have to play along a little bit here. Now, what happens to everything else? Well, I'm going to make a square root symbol here. Best I can do today, guys. And what's left over is this. So what do we have left over? We still had an x left over because we had 3 of them originally. We had an x left over. We had 3 of them. We've accounted for 2 of them when we pull them out. And we have a y left over. So we had 1. We couldn't pull that out. So we end up with 2 times x times z to the fourth times the square root of xy. Let's do the second example. Here the index is 3, so we're looking for groups of 3. When we do 32, 32 is 2 times 16, which turns into 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So when we're looking at 32, this is what we're looking at, right? So let's write this out all the way. Times A, times A, times B, times B, times B, times B, times B. Oops. 1, 2, 3, 4, 5, 6 B's. So this is actually what this whole radicand looks like. So now we're going to pull out groups of 3. So what do I, oops, let me do my, yeah. So out in front, I'm going to have 1, 2, 3, 4, 1, 2, 3, 4, 5 twos. So I can pull out one group of 3 there. So I have 1, 2 out front. There are only 2 A's, so I can't pull any of those out. And there are 2 groups of B's, so I have B to the second. Now under the square root symbol, what's left over? I'm going to have all the sort of leftover stuff that I wasn't able to pull out the first time. So under the square root symbol, I couldn't touch those 2 A's, so I still have A squared. By the way, this caret symbol is often used as a way of talking about this when we don't have the best editing equipment. And are there any 2's left? Well, there are, right? Because we had 1, 2, 3, and we had 2 left over. So this will actually be 2 times a to the second, or a squared. There were no b's left over because there were 2 groups of 3. So we're done. That's all it is. See if you guys can't complete the inside of this, and give me a call if you get stuck. I'll be back later to give you more information on the next set of problems. Hope things are going well. Miss you guys. Bye.